circular function, or we know Euler's exponential form is e raised to I theta equal to cos theta plus I sin theta. This is Euler's form. So Euler's exponential form, we say this one. Already we had explained this one, and that is how to get cos theta, sin theta and all. So if e raised to I theta is cos theta plus I sin theta, we know e raised to minus I theta will be cos theta minus I sin theta. By de Moivre's theorem and all, you can write this one. Otherwise, when it is e raised to I theta, here it is plus and here it is minus, means here it will be minus. So actually it is e raised to I sin theta, cos theta plus I sin theta raised to minus 1. Okay, in that way it comes here minus theta. Now if I add these two, when I add these two, what I will get is e raised to I theta plus e raised to minus, okay, we will write x here. No specific reason, just I am changing theta as actual form is Euler's form is e raised to I theta. So we will use x here, or z you can use. Okay, so now e raised to ix plus e raised to minus ix. We are adding these two. Then this will be equal to cos x plus cos x. You will get, these two will get cancelled. So you will get 2 cos x. Okay, 2 cos x you will get. And now if I take this 2 to the denominator, you will get cos x equal to e raised to ix plus e raised to minus ix upon 2. Similarly, if I subtract these two, this minus this, so what will happen? Cos x minus cos x, this will get cancelled, and I sin x, here minus minus becomes plus. So I sin x plus I sin x you will get, and you will get it as 2I sin x. 2I sin x is equal to e raised to ix minus e raised to minus ix. Okay, so if we take this 2I to the denominator, so when I take the 2I to the denominator, you will get e raised to ix minus e raised to minus ix upon 2I is equal to sin x. Okay, e raised to ix minus e raised to minus ix divided by 2I. This is sin x. So these two formula you need to note. Okay. Now this is circular function. Now the same thing. Now from here again you can get tan x. So if I want to get tan x, what to do? Sin x is here, cos x is here. So sin x upon cos x, if you are doing, you will get tan x. Okay, so I am not writing the formula here. So sin upon cos, you will get tan here. And now how to represent this one, hyperbolic function. So here, if x is a real number, we write all these things. Now if it's a complex number, means if z is a complex number, formula remains the same. Only thing is, if z is a complex number, then what you will write? Cos z. Cos z is equal to e raised to iz plus e raised to minus iz divided by 2. Similarly, sin z is given by sin z is equal to e raised to iz minus e raised to minus iz upon 2I. Okay. Now we will write. We will see what is the what are hyperbolic functions. So hyperbolic functions. How will you get hyperbolic functions? So the method of getting hyperbolic functions is that in this, say e raised to ix we have, if I replace that x with ix, means in e raised to ix, I am replacing x with ix. So e raised to I into ix you will get. Okay, so when you replace x with ix, we will get hyperbolic functions. So directly the formula will write, so that is cos and again, so we have cos x is equal to e raised to ix plus e raised to minus ix divided by 2. Just this I will show you. Then I am going to replace this x with ix. replacing x with ix. Okay, so this will be cos of ix is equal to e raised to I, x is replaced with ix, plus e raised to minus I into, again x is replaced with ix, divided by 2. So this is equal to e raised to, what you will get, I square x plus e raised to minus I square x divided by 2. This is equal to e raised to I square is minus 1. So minus x plus e raised to, here minus is already there, I square is minus. So that minus minus becomes plus raised to x divided by 2. So this is now cos ix. We write this as hyperbolic cosine, cos hx, cos hx. So cos ix is rewritten as cos hx. It is read as hyperbolic cosine. Okay, cos hx, this is equal to e raised to x plus e raised to minus x divided by 2. Similarly, we can get sin hx, hyperbolic sin hx. Hyperbolic sin is sin hx, which is equal to e raised to x minus e raised to minus x divided by 2, and from here tan hx you will get, tan hx is sin upon cos, this divided by this, so you will get e raised to x minus sin is this one, so 2 will get cancelled, so e raised to x minus e raised to minus x divided by e raised to x plus e raised to minus x. Okay, so this is tan hx, hyperbolic tangent. Now there are some relation between this circular function and hyperbolic function. I'll just tell that one, that is relation between, so these all you need to know. Okay, this proof and all you need not study, you have to just study this formula, relation between hyperbolic and circular functions. That is sin ix. Sin ix is given by I sin hx. Then cos ix is given by cos hx. Cos and sec, always they will be, means they will remain like this only, there is no I and all. So now tan ix, tan ix is given by I tan hx. So this is a relation between circular function and hyperbolic function. Similarly, cosec ix will be I cosec hx, sec ix, sec ix will be what, only sec hx. Sec hx means there is no I here. Okay, so cos and its reciprocal don't have any I before that. So then now if it is in the reverse way, that is if sin hix, sin hix, this is given by I sin x, I sin x. Similarly here also cos hix is cos x and tan hix is I tan hx, sorry, I tan x.